In question 8, we're looking at firstly undergoing row reduction, perhaps column reduction before we can make an assignment to minimize costs. Now I'm going to be looking at 8C in this case. So the smallest member I sort out in each of the rows, and I do a subtraction across. Now in this particular problem, I can just cancel out the zeros using 2 lines. So 2 lines only, therefore column reduction. Got to carry out some column reduction. You can see here that Y and Z haven't been allocated. Now in column reduction, I simply record or copy down the first 2 columns. And then I do the same, except I have to subtract in the next 2 instances. So 5, 10, 0, 0. And you can see here that I need a total of 4 lines to cancel the 0, or to cover the zeros, therefore can allocate. Now, clearly there's one assignation only for Z, and that therefore means there's one assignation for W. So B has to do W, and A has to do Z. Now that means also that we've got 2 alternative choices. There's nothing really to split the allocation of X and Y. So in option 1, what I'll do, I'll allocate C to X, and I'll allocate D to Y. And when I do a cost analysis of that, that's going to be 20 plus 10 plus 15 plus 20, $65. Now I've got to try the other option as well. So that means I can also allocate C to Y, and therefore C to W, I should say, and then D to Y. So flipping around the process there. Now that will still give me a cost of 20 and 10, but 25 and 10 in this instance, which will also give me a total of $65. So as long as you've got the 2 options spelled out, you won't go too far wrong in this particular problem. But important that you try both methods. With the problems we're now going to move on, we will be needing the Hungarian algorithm.